Yes, Rahul. How are you, brother?
I'm fine, sir. How are you?
Yeah, good, good. Meeting after a long time.
Con- yeah, congratulations, sir.
Thank you so much. But for what?
Sir, you know very well, Noida branch.
Why you didn't come
When?
in the webinar? I had planned webinar and I was expecting that you will be there.
Sir, I was busy that week,
Just
no?
few weeks ago. Hmm.
Okay.
But again, I am in Surat, but everything is working fine there, going well.
So, who is handling over there, sir? Your behalf?
Puneet is there, Mr. Puneet.
Okay.
Right, he is taking classes as well online from there for the automation. At the same time, he is
Okay.
managing the, like earlier, all the teams were working from the home, right? So they guys were not putting their 100%. This is the main
Correct.
reason of office. Not purpose is running the offline classes there.
But, sir, let me tell you, really, this week I had gone to office only, today only I had gone to office, and I did not do even a single task, worked on single task. And yesterday I worked on 4 to 5 tasks in
Hmm.
a day when I was doing work from home. Because you have a pressure on work from home, the manager would ping you
Yeah, there should be guys who can manage everything, right? If from the
anytime.
home. We cannot
Hmm.
manage. I can't manage from the
So,
employee from the home.
correct. बट
That
ऑफिस
was
में
the
सर रियली
challenge.
काम नहीं हो पाता सर.
हाँ, नहीं हो
इतना
पाता
इतना
बिल्कुल.
इतना काम नहीं हो पाता बिकॉज वहां पे कभी लंच ब्रेक जा रहे हैं सब लोग, कभी टी ब्रेक जा रहे हैं, कभी कि
एग्जैक्टली.
सुट्टा ब्रेक जा रहे हैं. वही चलते रहता है.
और
मतलब
काफी
नाइन
टाइम
आवर्स
से
में
मैं
से.
प्लान कर रहा था कि आप लोग एग्जिस्टिंग स्टूडेंट से मिलना है, क्लासेस करने हैं, और टाइम का इतना इशू रहता है कि हो नहीं पा रहा था.
सर अब कभी भी थोड़ा सा बिजी हूं मैं भी. अदरवाइज नोएडा कभी आओगे तो लेट मी नो, आई विल ट्राई
श्योर
एंड मीट
श्योर.
यू. हाँ जी.
श्योर श्योर. बिल्कुल. और आना तो होगा ही, फिर मिलेंगे ही.
हाँ जी, हाँ जी.
अभी अपन कुछ कुछ बीच बीच में कोशिश करते हैं ज्वाइन करने का, और कुछ टॉपिक्स है उसको कवर करते हैं,
जी सर.
है ना? और बताइए, रेस्ट एवरीथिंग इज गोइंग वेल?
यस सर. प्रोफेशनली गोइंग वेल अभी तो.
व्हाट अबाउट अदर्स, कार्तिक?
Yes, sir, going good, sir.
What about the enterprise knowledge? Are you guys still practicing the previous topics like the BGP and the switching, OSPF
Yes sir. I'm
services?
revising everything from the scratch.
And I am expecting now you guys are expert, champion.
Mhm. Mhm.
Will be one day.
Yeah, yeah, sure, sure, sure.
Sir, I would like to ask
Learning.
career
Yes.
guidance. I need support from your side. Last 10 years, I was working in Qatar as a normal IT administrator only, like a CCTV support and the Windows administrator, Linux administrator, and so. Just now, I'm entering into the courses. I
Linux.
have
You were a
completed some.
Linux admin in the last company?
Yeah, Linux and the Windows and everything, entire IT admin. This small organization, CCTV
Hmm. Okay, okay. Got it.
and a small firewall also it was.
So
So
are
now
you
I am
looking
fully
for
entering into
change?
this. Yeah, looking networking. Now right now I'm in India, not in Qatar. I leave my job. I am
Okay.
looking for the. So how to? I don't know. Just a small career guidance from your side.
So the career guidance is going to be, see, you are already done with CCNA plus CCNP,
Yes,
right?
sir.
And I am expecting you
Yes.
are going to become the champion. You, or maybe you already have completed all the topic. Now the next part is you need to work on your resume. Share your resume with me as well. Let me check it.
Okay.
How you have arranged all the topics there, and target some
Okay.
company where you want to see yourself in India.
Okay.
Right? At
Okay, sir.
least tell me the name of 10 companies, 10 networking companies where you want to get job. Accordingly,
Okay.
we'll see what technology they are using, that company. According to that, we'll add some topics in our resume. Maybe you need to learn few more topics or few more technologies according
Okay,
to
sir.
the big company needs, right? And this way
Okay, sir.
we can easily get job,
Mhm.
right?
Okay. Okay.
Definitely we
Okay, sir.
will also work with you to get job in better company, right? Even if you need the interview session, I will provide you one to one mock interview session as well. Okay.
Thank you, sir. Thank you. Thank you.
Most welcome. Anything else, guys? Anyone want to speak? Otherwise, I will start my session with wireless networking. Right? We learn a lot about wired networking.
Those
Getting noise from somewhere as well, so please put yourself on mute if there is noise. So what I am saying, we learn lots of things about wired network, right? Like I think 4 to 5 months. 4 to 5 months, we talked about wired network, up running the routing protocols over the link between the routers, configuring switching protocols, or the complete enterprise network, right? So many things were there. Question is, if everything is so good in the wire network, then why we need wireless networking? Why we need to learn one more types of networking, Praful? So who will answer to this question? Why we come up with wireless networking? Why behind wireless?
Sir, mobility.
Very good. One reason is mobility. Anything else?
Roaming thing, sir.
Roaming thing, right? We cannot move from one place to another place, from one floor to another floor in case of wire network, right?
Yes.
Anything else? About the guest,
Cheap guest, yes.
right? You cannot connect the guest devices to through Ethernet cable in your office. So for the guest as well, we need again wireless network. So my complete network is not going to be wireless, right? 60% networks are wired and 40% networks are wireless. See, wireless is getting popular nowadays. Nowadays, it is getting very popular, right? Everywhere you will find wireless network, right? Earlier, the size of wireless network was small, but nowadays we cannot say wireless network are like the small in size. It is LAN only local area network. It is WAN as well, right? Wireless, there are again exactly those all networks types comes under wireless, which we have under wire network, like the LAN, MAN, CAN, PAN, WAN. Those all types of network can design in wireless as well. Very good. That is why behind wireless, and many of you are already clear with the why part. Question is, Praful, what we are learning in the wireless networking? In wired, what we learn? We learned MPLS, we learned VPN, we learned NATing, we learned QS, we learned multicasting, we learned routing, switching, right? OSPF, BGP, EIGRP, RIP, static routing, STP, Ether channel. Those all were the topics of wire network. In wireless, what we will learn? See, in the wire network, guys, if I will talk about the wire network, in wire network, which centralized device you are using to connect multiple devices together, or multiple LAN devices, multiple servers, client machines? Which centralized device are you using?
Access point, sir.
In wire,
Achha, wire में switches we are using L2 switches.
L2 switch, right?
Yes.
Layer 2 switch, access switch. Here in the wireless networking, we have again the centralized device which can be used to connect multiple end machines, wireless clients, wireless devices together, which is called your AP, access point. So the first thing which we need to learn about wireless networking is our access point. And before access point, definitely there will be some basic wireless concept that also I am going to include. Let me talk about the components of wireless networking. Okay, apart from the access point, think about wire network again. In the wire network, let's suppose you have switch, access layer switches. Lots of access layer switches are there who is connecting lots of end devices. How you are managing access layer switches, guys? How we are managing the access layer switches in the production? In nowadays, how we are managing our LAN network?
Sir, via TechX we are managing the devices.
Nowadays, we are managing through SD access, right? The SDN solution through which we are managing our LAN devices like your access layer switch, distribution layer switch. So STXS is controller based networking, the software. Similarly, here we have one component which is used to manage multiple APs. STXS is used to manage multiple LAN switches. Similarly, here we have one controller that is called WLC to manage the multiple access point. WLC stands for wireless controller. Like WLC can be used to create a wireless LAN, right? LAN and the virtual LAN or wireless LAN, both are same. Difference is in term of media. In wire, when I am saying LAN, local area network, that means I am talking about physical media between the devices. And when I am saying WLAN, wireless LAN, then I am talking about the local area network where media is air. Am I right? So how to create the LAN and how to create the WLAN? Both are what? Implementing network in a small geographical area. Right? So like creating WLAN can be done with the help of WLC. Whatever configuration management are there on the AP, those all tasks can be done with the help of WLC. So that's why I'm saying WLC is our second component which you need to learn.
So it
Then
is just like we manage in
yes,
SD-WAN.
yes,
Okay.
exactly. We in SD-WAN vManage is used to configure lots of routers, lots of WAN edge devices. Similarly,
Mhm.
here WLC can be used to manage or configure multiple APs, access point, multiple APs. Like in the company, if I have thousand number of APs, right? Then configuring, managing those AP can be difficult manually. So here WLC will help you to manage or control your all AP through WLC. And if you have the multiple WLC, guys, if you have the multiple WLC, then how you will manage lots of WLCs? For an example, the Google has lots of data center storeroom around the globe, and everywhere they have wireless setup. Means so many access point will be there in their network. Yes, so many WLC will be there. So how they will manage their WLC, their controllers through Cisco DNAC center, right? So third component is going to be Cisco DNA center. By the way, Cisco has changed the name of DNA center to Catalyst Center nowadays. Nowadays we are saying Catalyst Center. By the way, both are same. Your WLC is used to manage the AP and DNAC center is used to manage multiple WLC or Catalyst Center. So this is the third component which you need to learn. After that, how AP and WLC are going to communicate. You know how two private site will communicate over public network? How to?
Via VPN.
Yes, via VPN, right? We can get the GRE or IPsec, am I right?
Correct.
Similarly, how WLC and AP are going to communicate? They will also establish some kind of tunnel.
CapWeb.
Yes, CapApp. So third component which we need to learn here is CapApp. CapApp is similar like your GRE tunnel between your AP and WLC. You can also include the Meraki because Meraki access points are also in the market, right? Like Meraki switches are for a small setup. Like if you have 5 to 10 clients in the office and you need to connect them together, you can use Meraki switch, right? And many times we are using it in the industry. So Meraki is also manufacturing the access point. So we can include the Meraki as well. But as per our CCNA plus CCNP wireless part, we don't need to talk about Meraki. Even in CCNA, CCNP, we don't need to master the wireless networking, but we should have the basic understanding. The theory parts are there. And even I am going to show you the practical as well. In packet tracer, we can design the wireless network as well, right? We can see the WLC configuration or access point configuration. Then we have different types of access point. Do you know how many types of access points are there? types of APs. We need to learn types of APs as well, like the standalone AP, lightweight AP. Do you know, guys, about these types of APs?
Not aware, sir.
The standalone means the AP which can be managed manually, right? Which cannot be managed through WLC. That type of AP is called standalone AP. That is called a standalone AP. And the second type of AP is lightweight AP, the AP which can be managed by WLC. That AP is called lightweight AP. So there are two types of AP which we need to learn. Then we need to learn wireless network infrastructure. Wireless
So, so first one is standalone is managed by
manually.
manually.
Yes.
Okay.
Wireless infrastructure means how to design the wireless network, what components will be there, how you will connect the APs, right? How you will connect the WLC, the DHCP server is required or not required, right? Which field will in the DHCP offer message will carry the WLC IP address, right? So we need to talk little bit more about the DHCP as well here, about the option 43 in DHCP if you don't know. Then see, there can be two situation. Situation number one, my access point and my APs, sorry, my APs and my WLC both are located at same site. My WLC and my access point, all the access points, all are located at same sites. Situation number one. In situation scenario number two, my APs and WLC can be at different sites, right? And both are connected through service provider network. So these are two infrastructure. Your WLC and AP are at different location, and the first scenario was access point and WLC both are at same location. So we have the local switching and flex switching, right? So you should have basic idea about the local switching or local mode, we can say, and the flex connect mode.
So at
Flex
same both the things at same site is local mode,
local means the your access point and the
and
AP.
WLC.
Yeah, sorry, access point and WLC controller both are located at same site. That type of setup is called local mode.
Okay.
And flex connect mode means my AP is at different site and my controller is at
Different
different
site.
site.
Centralized WLC, you can say.
Correct. So these are the topics which we need to learn in our wireless networking. If I will talk about the CCNA 200301, and some more topics are pending, right? I think virtualization is done, right?
The virtualization is pending. Multicast is also pending, sir. PBR is pending.
So in the last class we had the session on multicasting only, I think.
Nice, sir.
No, sir, multicast.
QS we did.
Okay,
Last time
okay.
we did
Last time
QS.
we did QS. Okay, okay. So right now I am talking about CCNP Enterprise and CCNA 200301. According to these two papers, we have some wireless topics, and these are the wireless topics which comes under these two papers. Enterprise means 350401 means in core, right? Now apart from these are the major part of wireless networking, but guys, you can only understand this if you have the basic fundamental of wireless, right? You should have idea about the radio frequency, right? Let me talk about the basic wireless components. Basic or wireless fundamental, I can say wireless fundamentals. Wireless fundamentals. Under wireless fundamentals, you need to learn the basic radio frequency. Can anyone tell me what is radio frequency? You should have idea about the channel.
2.4 and 5, sir. 2.4 and 5 G.
2.4 and 5 are two frequencies used for wireless communication. That is good. Channel, what is channel?
Wave band, sir.
Band.
Yes. It's
So the
a
radio yeah,
wavelength.
wavelength. By the way, wavelength is different thing. These are the basic wireless fundamental: radio frequency, channel. Then I can say SSID. What is SSID? I can say BSS, ESS, and IBSS.
Sir,
Then
BSA.
hmm?
BSA.
Yeah, BSA
Basic
is also there.
service.
Yes, BSA. Then we have a standard. May I know the standard for wireless communication? Which standard we are using for wireless communication? 802.11. 802.11, and the 802.11 is the main family, and there are so many family members of this standard, like 802.11a, b, g, n, ac, ax. These are different standards, so you should have basic knowledge about the standard as well. Then I already told you about the infrastructure, about the topology, components, and then last thing is these are the basic fundamentals of wireless, like the basic routing and switching, the packet flow in the wire network. Then about the security, we should also have knowledge about wireless security. Wireless security, like we have multiple protocol for wireless security. Many of you already know about the AAA server, TechX server, right? I'm talking about the authentication. Those servers are used for authentication. Here we can configure some protocols for security like WPA, WPA2, WPA3, PSK, pre-shared key. Right? And we need to learn the authentication method as well. Methods. Right? After that, if you will talk about the wireless networking protocol REST, what about the REST syllabus, which are not the part of CCNA and CCNP, but we have in the wireless. So guys, the advanced wireless security, advanced controllers, like the deployment configuration of WLC. Here we don't need to learn the WLC configuration, right? Then T-suit, troubleshooting, like you troubleshoot OSPF, EIGRP, BGP. Similarly, how you will troubleshoot the wireless network if there is any issue, right? About the issue regarding to channel interference. These type of issues comes in wireless network interference, overlapping channel, non-overlapping channel. So you should have idea about this. And then finally the deployment. That is the topic which you need to learn in core wireless course. Deployment. That is all about our wireless networking. So let's begin
What is
from the basic.
RSSI, sir?
We are going to see.
RSSI?
We are going to see it. Don't worry.
Acha, okay.
This can be the issue comes in wireless networking, which you need to fix. So guys, before talking about access point or WLC, let's talk about this wireless fundamental first, and after that will come on the components. And here I have packet tracer as well for the lab. At the last we'll design one wireless network, and we'll see the WLC and access point configuration there. Okay. See, what is wireless networking? Connection between source and destination is established through radio frequency signal. Is termed as a wireless network. Radio frequency is going to help to link two devices wirelessly, right? Here, because media is ear, and guys, wireless networking is even not secure like wire network. Security is very important because your data is going to travel in air. Yeah, right? You can see in wireless communication, data travel in air. If I will talk about the standard, so you can see for the wire we have 802.3, and for wireless we have this standard 802.11. Why we come up with wireless networking? You guys already told me that for mobility, for a small devices, mini devices like the smartphone, tablet, laptop, even most of the today's laptops comes with USB port only, right? You will not find RJ45 ports there, so it will be difficult to connect with wired. It will be very easy to connect your laptop to the network through wirelessly. Question is, what is frequency? Frequency is nothing but the number of cycle per second, right? You know, in the wireless, your data will travel in wave. Your data will travel in wave, not in a state. Your data will not travel like this. Data will travel like this in the wave. Guys, 1 minute, please. So when your data will travel in wave, so what I am saying, whatever cycle a data will cover in 1 second, that will be your frequency, right? Let's say data is covering 4 cycle in 1 second, then I can say what? Frequency is 4 hertz. We can say frequency is 4 hertz. Like this. Here somewhere you will find, you can see this one like this. And can anyone tell me what we called here to here? What is this? Here to here, not here to
Frequency or wavelength?
wavelength, right? The distance between two peak points is called wavelength. Let's talk about frequency first. Frequency is nothing but the number of cycle per second. And guys, two frequency.
Sir, as per diagram, can you show us what is the cycle you mean? कहाँ पे complete हो रही cycle? Diagram में जो नीचे है आपका.
नहीं, cycle ये एक cycle हुआ. One up and one down is called one cycle.
Okay.
This is called one cycle, right? And in 1 second, whatever cycle it is completing, that is called frequency.
Frequency.
Okay.
For wireless communication, mostly we are using two frequencies. One is 2.4 gigahertz and another one is 5 gigahertz. These two frequencies are used for wireless communication. There are many more frequencies and we don't need to learn it, like for the radar, which frequency is used, for the microwave, which frequency is used, right? And all the frequencies are not good, right? Most of the frequencies are harmful for our body, right? So these two frequencies are used for wireless communication, 2.4 gigahertz and 5 gigahertz. Always keep in mind these two frequencies. Can anyone tell me the difference between 2.4 gigahertz and 5 gigahertz?
Sir, 2.4 में the speed is slow, but the range is far. But in 5 gig, speed is fast, but range is too less.
Yes, because see, 2.4 gigahertz is completing how many cycle in 1 second? 2.4 multiplied by 10 raised to power, I think 10. Because it's not hertz, it's gigahertz.
2.4 into 10 raised to power 8.
I think 10.
Okay,
We'll see it
okay, okay.
in the PDF. That value will be there. Okay.
The
So
5 gigahertz it will not
5
overload.
gigahertz is completing more cycle in 1 second, right? That means their wave is going
Yes.
to be like this, and 2.4 gigahertz wave is going to be like this, right? So here wavelength is more than 5 gigahertz, and wavelength is directly proportional to range. High wavelength means high range, but speed is inversely proportional to wavelength. So
Sir,
here
repeat
speed is
this
going to
thing
be
again, sir.
slow, here speed is going to be fast, here range is going to be high, here range is going to be low.
Sir, repeat
In
this thing again,
2.4
sir.
Yes.
channels will be interfere.
Now, under 2.4 gigahertz and 5 gigahertz, we have again many more frequency. This is, guys, range. This is not one frequency. These are the range of frequency. When I am saying 5 gigahertz or 2.5 gigahertz, these are the range of channels. There are so many channels inside this frequency. Let me tell you about that. Before that, here it's mentioned about the standard like 802.11b. Okay. Some standard
Sir,
operates on 2.4 gigahertz, some standard operates on 5 gigahertz, and these standards are categorized in term of speed, range, right, compatibility with 2.45 and standard. Yes, brother.
सर एक बार वो इनवर्सली प्रोपोर्शनल डायरेक्टली प्रोपोर्शनल वाले थिंग कैन यू रिपीट
बता
इट?
रहा हूँ बता रहा हूँ नीचे है सब कुछ डिटेल में,
ओके ओके ओके
right? So these all standard operate within these frequency band means range of frequency. Each provide different data rate, different performance, different compatibility, and uses radio frequency to transmit or receive data, right? So how you will create WLAN, wireless LAN, with the help of radio frequency? Radio frequency enables the wireless transmission of data between the devices, which allow you to create a wireless local area network, right? And radio frequency, if you want to know more about the radio frequency, so radio frequency is nothing but the combination of electromagnetic wave, means electric wave and magnetic wave are there. That's why I said it is not good for our body, it's harmful. And electromagnetic wave do not travel in a straight direction. That's why I'm saying in wireless your data will travel in wave. This is the nature of electromagnetic wave. Electromagnetic wave always travel in wave direction, and your frequency is nothing but the combination of electric and magnetic wave only. Here are the information about the cycles, about the basic idea about the cycle again, like when one wave complete up and down cycle, so that we can call it one cycle, right? It can represent the peak to peak point. Frequency equals 4 cycle per second, it means frequency is 4 gigahertz. And this is the wavelength representation. Here you can see, here I am saying low frequency because wavelength is high, and here wavelength is short, that's why I'm saying high frequency means speed. Frequency is directly proportional to speed, right? High frequency means high speed. Here are the unit of your frequency. You can measure your frequency in hertz, kilohertz, megahertz, and gigahertz. When I am saying giga, see how many zero are there? 3, 9. Total 9 number of zero are there. 10 to power 9. The frequency range between 3 kilohertz to 300 gigahertz is called as a microwave and radar. We don't need to learn it. When I am saying 2.4 gigahertz, it means 2.4 multiplied by 10 raised to power 9 cycle per second. When I'm saying 5 gigahertz, it means 5 multiplied by 10 raised to power 9 cycle per second. And here are your all standards: 802, 802, 802.11, 802.11a. 802.11 support 2.4 gigahertz and it provide up to 2 mbps of speed. That's it. 802.11a supports 5 gigahertz frequency and provide up to 54 mbps speed. You can see the difference in speed. Again, 802.11b operates on 2.4 gigahertz frequency and it provides up to 11 mbps speed. 11G 2.4 gigahertz up to 54 mbps speed, and it is compatible with 802.11b as well. G and B are compatible with each other. 11.n operates on both the frequency, can operate on 2.4 as well as 5 gigahertz. Today's access point, today's even our home routers operates on both the frequency. You can change the frequency. Even I can change the frequency of my wireless router. If I will try to access my wireless router here, 192.168.1.1, here you can see username admin. I think I cannot log in with admin. By the way, this is not access point, guys. If I will talk about the home router, what is the difference between home router and access point, or home router and enterprise router? Home router,
Sir, home
राउटिंग में
router,
सर
all
राउटिंग
all
स्विचिंग
compatibility.
सब कुछ एक ही जगह होता है होम राउटर में.
home router is a combination of multiple devices like your router. It is performing, it has some features of routers like performing routing, some features of switching. Switching means we can connect multiple LAN devices as well through wired. That is switching. And the third thing is access point, AP. It can connect devices wirelessly as well. And some extra features are available on my home router like the NATing, QS, security, right? So it has also the firewall capability. So home routers are combination of basic router, basic switch, basic access point and basic firewall. Here we are learning about the pure access point. Right? In the packet tracer you can have home router as well, I think. Yes, here you can see the home router is there, guys, right? Home router is there. If I will connect a PC over here, or I can access my home router as well. LAN interface 0.1 IP is correct. Yeah, now ping is working. I can access it through browser. One 192.168.0.1 was the IP, I think. Yes, you can see it is asking for username and password. By default, username is admin, I think. Password is also admin. Yes, you can see I got the access of my router, guys.
Basically the AP which is at home, right?
Yes, the same
Sir, but
AP.
we did not give any gateway to the PC or something like that.
No, gateway is not required to access it, na. To forward the traffic to different network, gateway is required. Here my PC is
Okay.
directly connected with router.
Hmm.
So see, I can create wireless network from here, right? I can configure the SSID. I can enable the DHCP service, security administrator. All features are there on my home router. Like the routing, you can configure the routing also here. You can configure the LAN network. You can also configure the WLAN network. If I will take you to the physical, here you can see how this router look like. Physical. See how many ports are there? 5 ports are there total, right? One is internet port, WAN port. The green port is your WAN port, and all the yellow ports are your LAN port. Means it is behaving like a switch. Here I can connect 4 clients, and if I can connect it to internet, that means it is behaving like a router. And when I am able to get WLAN here, that means it is behaving like a access point. True?
Correct, sir.
I'm not able to recall the password of my actual AP. Otherwise, I can log in here and I can show you. Like you can try it with your router as well, right? Somewhere there will be option to change the frequency from 2.4 gigahertz to 5 gigahertz. Let's suppose you are near to your access point or home router. Then you can operate your AP on 5 gigahertz. You will get the better performance, better speed. And if you have this issue with signal, sometimes signal is weak in your bedroom, then you can operate your AP on 2.4 gigahertz. So these are different standard, and here you can see the compatibility and their speeds. And here are the detailed information about each standard, like provide a speed up to this, range approx 35 meters indoor. This standard is for indoor, for up to 35 meters distance, right? Widely compatible but outdated. It is not in use. Introduced in 1999, right? Operates on 2.4 gigahertz frequency. Then about this you can read about 11G. You can read which was introduced in 2003, right? Provide up to 54 mbps of speed. Sorry, N11N was introduced in 2009, provide 600 mbps speed. This is throughput, and it operates on both the frequency. You must have heard about the Wi-Fi 5, that is 11 AC. It can provide a speed in Gbps, right, and operates on 5 gigahertz. Wi-Fi 6 again can provide you a speed in Gbps, and it was introduced in 2019. This one is the modern one, right? This one is the modern standard. Now the other parameters, the fundamentals concept of wireless networking, that is band and channel. Hope frequency is clear. Any question in frequency? Okay, see the wireless bands and channel. As you know, the range of IP address is represented by network ID. What is network ID? The main family member, parents, and the IP addresses are called host. Host 1, host 2, host 3, right? These are the IP address like 10.1, 10.2, 10.3, and the network ID is 10.1.1.0/24. Right? As the range of IP addresses is represented by network ID, in same way, a group of frequency is known as wireless band. When I am saying band, that means I am talking about the group of frequencies. I'm talking about group of frequencies. Group of frequencies is called band, wireless band. What is frequency? Number of cycle per second. What is band? Range of frequency is known as band. For wireless communication, we have two frequency, 2.4 and 5 gigahertz. And here is the difference between 2.4 gigahertz and 5 gigahertz. Here you can see the difference, or you can take one screenshot of it. 2.4 gigahertz provide you lower speed, longer range, and more radio frequency interference. This is the bad thing. 5 gigahertz fast speed, shorter range, and less radio frequency interference. Interference is disturbance, guys, right? This is the disturbance. I'm going to show you how with the overlapping example. Then frequency range, you can read about the frequency range of 2.4 gigahertz and 5 gigahertz. The difference in term of range, difference between 2.4 gigahertz and 5 gigahertz. 2.4 gigahertz and 5 gigahertz in term of frequency range, in term of speed, in term of interference, like in term of interference 5 gigahertz is better. In term of range 2.4 gigahertz is better. In term of device compatibility, 2.4 gigahertz and 5 gigahertz. Frequency unit, we already seen that. Interference is nothing but the disturbance, the unwanted signal, right? Interference means when unwanted signal disrupt the communication between devices in wireless network. This can result from overlapping frequencies or environmental factors like the wall or the metal object between the devices, or other electronic device emitting signal in the same frequency range. It can cause the interference. Interference can decrease signal quality, right? It can slow the data rate. Customer can complain about the complete connectivity loss, right? So which technique we are using to avoid the interference? We have understood that interference is something called disturbance, unwanted signal. So guys, there are some technique which we are using to avoid the interference, like the frequency hopping, speed spectrum modulation, and proper channel planning can improve the quality of your wireless network, right? So if you have the knowledge of wireless, then only you can plan the proper channeling, like where, on which channel you are going to transmit the data from a particular AP. If two AP are there in the one room and both are transmitting the traffic on the same channel, then there will be disturbance, right? We can lose some data there. So these are different techniques: frequency hopping, spectrum modulation. These are technique. Now let's understand more about 2.4 gigahertz frequency and channel. It should be frequency. See, 2.4 gigahertz frequency band extend from 2.400 gigahertz to 2.483 gigahertz, and trust me guys, you don't need to remember it. You don't need to remember the range. Even I don't remember the range of this frequency. 2.4 gigahertz is what? one central value. This is one central value. But the actual frequency of 2.4 gigahertz means which is starting from here and ending over here. From here to here, all the frequency comes under 2.4 gigahertz. Right? So what is band? Band is group of frequency, Praful. Group of frequency. That means 2.4 gigahertz is a band because here we have lots of frequencies. And again we further divided band into multiple channel. The subdivision of band is called channel. Again I am repeating, what is frequency? Frequency is number of cycle per second. What is band? Band is group of frequency, range of frequency. And what is channel? Channel is nothing but the subdivision of your band. Right? Here you can see this band is further divided into sub band called channel. And these channel are assigned to Wi-Fi device like your laptop, mobile phone, tablet, any wireless devices, and even access point to communicate with each other. All wireless devices are going to communicate with each other on a particular channel.
That would be same for all the devices. Suppose I am sitting at home and I have laptop and mobile as well. So they would be communicating with the access point
Yes,
at
on the
same
same
channel.
channel. Yes.
Okay.
On the same channel. And let's say your neighbor is also has my access point. They have also the client machine. And if they are also transmitting the data on same channel, then you can find some area there will be interference. Right? So if you are getting interference, slowness, you can shift your channel. You can change your channel on your home router or on your access point. So 2.4 gigahertz frequency is nothing but the range of frequency. That is called 2.4 gigahertz band. Band means range of frequency. And the subdomain of band is called channel. The range of this band lie from between this to this gigahertz, which represent 2.4 gigahertz. What I told you, this is the central frequency. This is the central channel of this range, the central number. So total, see how many channels are there under 2.4 gigahertz. Your first channel will start from here, 2.400, right? So this channel is going to be what? 2.400. First channel is 2.400. First channel will start from 2.400 and it goes to 2.423. This is not the last range, 243. There is a gap of 22 megahertz. Right? First channel will start from here and it goes till here. So we can say the first channel occupied 22 megahertz. And the middle frequency is called central frequency, and that is called your channel. So channel is known as central frequency. Right? So this is my first channel, channel number 1, 2.41. हेलो हेलो, am I audible?
Hello. So आपकी voice चली गई बीच में.
अभी आ गई?
Yes sir, now it is fine.
Okay, great. So there was issue with electricity. Okay, so the first channel is starting from here and it is going till here, right? And the central frequency is called channel. The second channel is starting from here and it is going till here, right? So the central frequency is called channel. This one is channel number 1, channel number 2. Now see, channel number 1 is covering this area. For an example, channel 1 is covering this area, channel number 2 is covering this area. So are you guys able to see the overlapping area here?
Yes sir. Intersection.
Yes. So this is the issue. If I need to install two AP, I cannot operate AP number 1 on channel number 1 and AP number 2 on channel number 2. If AP1 is going to transmit data on channel number 1 and AP2 on channel number 2, then there will be interference at this area, at this place. Getting my point? So if you have two access point, then how we will plan the channel, right? What should be the channel number on AP1 and AP2? AP1 and
1
AP2.
and 4 maybe.
1 and 4.
1
As per
6.
diagram.
See, 4 is this
1 and
one
6.
and 1 is this one. Still there is
Sir,
1 and 5
overlapping
then.
area.
1 and
6.
6.
6. Right? See, this channel and this channel are not overlapping, right? And this channel are not overlapping, right? So how many non-overlapping channels are there under 2.4 gigahertz? 1, 6 and 11. And this is very important for interview. In interview, many time interview is asking what are the non-overlapping channels available under 2.4 gigahertz. So you can say 1, 6 and 11, or we can also say 2 and not 2 and this one, 2 and 7, 2, 7 and 12. These are also non-overlapping channel, right? So
Yes,
this
sir.
is our proper channel planning, right? We need to avoid the overlapping area, and you know, don't need to go in detail. Here you can read this PDF, everything will be clear to you. Like the channel first channel number second will start after the gap of 5 megahertz, right? So if you will see the difference over here between two channel, you will find the difference of 5 megahertz. This is the gap between each channel, right? So there are 3 non-overlapping channel available in 2.4 gigahertz, but these channels are overlapping, which create interference with each other. So if two devices are using the channel from 1 to 5, they can overlap with each other. Selecting the proper Wi-Fi channel can improve your Wi-Fi coverage and performance. In 2.4 gigahertz, channel number 1, 6, 11 are only non-overlapping channel, or you can say 2, 7 and 12, or you can say 3, 8 and 13. These are non-overlapping channel. Selecting one or more of these channel is an important part of setting up your wireless network correctly. Total number of channel available in 2.4 gigahertz is 14. How many channels are there? Total 14 you can see. But how many non-overlapping channels are there? 3. Either these 3 or these 3. But one channel number 1 and 2 will always overlap with each other. Similarly, if I will talk about the 5 gigahertz channel, so guys, in 5 gigahertz we have these channel, and you can see all are non-overlapping, right? The channels are not overlapping under 5 gigahertz frequency. So these are the basic fundamental knowledge of wireless networking, and if you have curiosity to learn more about it, then you can definitely learn, but this is more than sufficient for your CCN and CCNP wireless paper.
And sir, if overlapping would be there, then loss of signal or interference would be there, right?
Yes, slowness, maybe complete slowness. There will be issue in roaming. You know the roaming. What is roaming? The very important topic of wireless. Roaming means moving from one AP to another AP. Let's say this is the building, and in this building there are 2 floors. At both floor we have AP1 and AP2 here, right? And you are sitting here at ground floor, first floor, right? So if you are sitting here at ground floor, that means you are connected with AP number 2 wirelessly. You will access internet, or you will communicate to your colleague via AP2. But if you will move from ground floor to floor number 1, automatically your device will detect that, okay, now when you are at first floor, then I am getting better strength signal from this AP, from the another AP. When your device, client device, is connected with AP, it will be keep scanning other AP as well, that hey, is there any other AP available from where I am getting the better signal. So once you will move from ground floor to first floor, automatically your device will detect that now I am getting better signal from AP number 1, and it will change the AP, right? So moving client from one AP to another AP is called roaming. If there is interference, overlapping, right, you will get issue in the roaming as well. It will like seamlessly you cannot move between the AP if you are going to cross the area where channels are overlapping. Before setting up the wireless network, guys, a proper site survey is very important. Like you need to measure the place where you are going to place the AP. It is not like in the company anywhere we can install, like home. In the home, anywhere we are placing the home router, am I right? But in the company, when you will set up the wireless network, there will be site survey. That is going to be first step, site survey, where they will measure the place, the central place where they are going to install the AP. They will use different kind of tool technique to find the overlapping area, to avoid the overlapping area. Right? So there are so many things to set up the design the wireless network as well, similar like wire network. So that's why we are saying make sure our channels should not overlap with each other. Right now here we have the wireless.
And
Yeah,
and
go
sir,
ahead.
in 5 gigahertz, there is no possibility of interference
Yes,
or
no
overlap.
possibility of interference. All are
Okay.
Sir,
non-overlapping.
sir, one more thing. If we are selecting the channel band as 2, 7, and 12, as you said, so it is a this Wi-Fi gives us to set these values or something like that.
We will have option to configure it, na? To
Okay.
configure the channel. Either I can configure on access point directly manually, or I can configure it through our controller WLC.
Okay.
Right? So these was, guys, the fundamentals of wireless. Fundamentals. Hope it is clear now. Now let's understand the wireless network components. The first component is access point, and many of you already know about the access point. It is a wireless hardware which provide wireless connectivity to devices, to the wireless devices. They act as a bridge between your wireless client and a wired network. Right? For an example, I have one infrastructure. Here I have some clients, PC, server, printer, IoT devices, right? Those all devices are connected through one switch. And this switch is connected with one, let's say, router, and router is connected with internet, ISP. This is my setup. Now here I have some guests, and these guests need internet access, or maybe access to any server which is located in my internal network or in my data center anywhere.
Or
But
printer as well.
yes, so we need to connect, and even we need to separate the guest from our network. If we are going to connect the guest through wired, then how you will separate it? Through VLAN only? You will create VLAN here. Am I right? Yes.
Correct.
So in the wireless, also we will have concept of VLAN. Like let's say I need wireless networking for our students, our guest, right? So I will be transmitting multiple SSID. For the guest, there will be guest Wi-Fi, guest wireless network. For our student, there will be a student Wi-Fi network. For our teacher, there will be a teacher Wi-Fi network. So how we will provide the wireless connectivity to these clients? Through access point, to this access point. Here you will connect one access point to your switch, and then access point will start transmitting SSID, and these devices will see what is the process to connect AP, how a client will get connected with AP. right? And this particular thing is called standalone, because here you can see we are managing our AP manually. Who will configure this AP? You will configure this AP. Network engineer will configure this AP. If there is any issue, who will troubleshoot? Network engineer will troubleshoot. There is no any controller. That's why we are saying this is a standalone AP. If this is my lightweight AP, then I can also add one WLC here. I can add one WLC here. And my AP is going to join my WLC, right? It will establish one CAPAP tunnel between AP and WLC to communicate, right? There will be one DHCP server as well, so that your wireless clients can get IP address automatically, or your access point will get IP address automatically from the DHCP server, or your access point also need the IP address of WLC, right? Because access point have to discover the WLC. Where is the DHCP? Similar like DHCP server. How a client machine discover DHCP server, guys? Through DHCP discover message. Yes. Similarly, your access point need to discover your AP, so your WLC, and access point need the IP address of WLC. So here DHCP server is responsible to provide the WLC IP to my access point as well.
So that WLC IP would be static only, right?
WLC IP
Supposing,
address, yes, it will be a static. And even on the DHCP, you can reserve the IP address for WLC,
yes,
na?
reservation, yes.
Yes. Right? And similarly like this, if I have lots of WLC, let's say there is one switch, so many APs are there, AP1, AP2, AP3, right? And this side is in Delhi. I have another side somewhere, switch in Mumbai, let's say. Here also I have lots of AP, AP1, AP2, AP3, let's say 100 APs are there in each sides, right? Here I have one WLC. Here also I have one WLC, WLC1, WLC2, and like this, if I have 100 number of sites, and at each side I have one WLC, guys. So that means 100 WLC are there. So here we need what? DNA center. DNA center, right? All the WLC are going to join your DNA center, right? Here you will have the dashboard, right? In the Meraki also, how you can manage the Meraki access point with Meraki dashboard. In any browser, you can access your Meraki dashboard. From here you can manage the entire infrastructure. The interesting thing is going to be how will be packet flow profile. Now if there is one user on this AP1 who want to communicate with a user who is connected on this AP, or there is one user on AP1 and here is one user on AP2, how these two AP are going to communicate? Definitely these two users are going to communicate via WLC, not via switch. Because guys, between the AP and WLC we have tunnel, right?
Yes.
So through tunnel, AP will forward traffic to your WLC and WLC will forward it to another AP. WLC is going to maintain a database, similar kind of table like your MAC address table. What happened to like
So
1 minute?
tunnel means sir GRE tunnel?
No, WAPCAP tunnel.
Also.
CAPAP tunnel. CAPAP. Wait.
So sir, for CAPAP tunnel also some configuration we needed, or it is by default enabled?
Automatically your access point will store the configuration from WLC. We need to configure WLC.
So same kind of scenario like means out DNS tunnel or either signature matching.
Yeah, I am
happen.
going to show you that in
Okay.
packet ration, right? So access point is a wireless networking device which is used to connect wireless client to the wire network. My main infrastructure is still wired. So I am connecting wireless client to the wired network. And here are the use of wireless. Then we have controller. The next component that we can discuss here is antenna. There are two types of antenna, guys: omnidirectional and directional antenna. Wireless NIC. Let me discuss all one by one. Controller, centralized management of multiple AP is called WLAN controller, right? WLC. Centralized management. From one centralized WLC we can manage multiple APs, like providing the configuration, pushing the security policies, or monitoring your AP. Here is the example. Then antenna, enhance the signal range and direction of your access point. There are so many types of antennas in the market, right? We cannot discuss all here, but after this class you can read one article on the internet about the antennas, right? Many times you will find in the market different devices, different access points with multiple antennas, right? This AP has single antenna, this AP has two antenna, some APs has four antenna, right? So single antenna can be also used to transmit or receive data. There can be two antenna, one to transmit, one to receive, or both can be used to transmit and receive. So if we have the more antennas, we can cover more areas. One antenna can cover a specific part of area, like in the warehouse. See, in the large warehouse, directional antenna are used to focus the signal in a specific area. Through antenna we can cover a specific area. Let's say I have my wireless network, and this AP is transmitting the signal in this range, and there is one a small space here, someone is sitting over here, but range is not there. So we can add one antenna to cover this range as well. So antenna is used to enhance the signal quality, the range. And like we have the physical for NIC for wireless networking, similarly we have wire networking. Similarly I have NIC for wireless networking as well, right? There is no any difference between wired NIC and wireless NIC. Both looks like same. Allow device to connect to the wireless network. Let's suppose you have the desktop, and guys, on the desktop by default there is no Wi-Fi NIC. So what you can do, you can purchase the Wi-Fi NIC from the market at 100 rupees or 200, and you can connect it at your in your desktop. After that you can connect your desktop to wireless network. So wireless NIC is required everywhere on every wireless devices, whether it is your laptop, desktop, IoT devices, or access point and WLC. If you want to connect two access point also wirelessly, both should have wireless NIC. Then the firewall, authentication server like the TechAC, Radius, AAA server. We can have the future of IPS IDS here as well in the wireless networking. Do you guys know IPS and IDS or not? Tell me,
No,
Frank.
sir.
IPS IDS is similar like your firewall. Firewall allow or deny the traffic based on pre-configured rule,
Correct.
right? Your firewall is not going to detect the virus. IDS is used to detect the virus, right? Intrusion detection system, right? It will detect the intrusion, and IPS stands for intrusion prevention system. If there is an intrusion, then it will prevent it. It is similar like your firewall that can be used in wireless networking as well. spectrum analyzer, I told you that before implementing the wireless network, we need site survey. So these are the tools which are in use to optimize the channel, right? A spectrum analyzer, see, analyze the wireless spectrum to identify interference and optimize the channel use. Through this tool, we can identify the interference area. In the crowded urban area, a spectrum analyzer is used to detect interference from neighboring Wi-Fi network and non-overlapping device, which is helping to optimize channel selection for better performance. Okay. Then again, there is some information about the access point. Access point is a crucial component in the wireless network for the Wi-Fi.
We have to remember lightweight and standalone only.
Yes, yes. If in the interview someone is asking types of AP, you should say standalone and lightweight. Function of your AP. See, AP can not only connect wireless devices to the wire network or to the network, it can also extend the coverage, right? Let's say I have the existing network and I want to increase the coverage area. We can use our AP in different mode, right? In that case, it will just increase the range, like, you know, it will increase the area. Where is my pin? 1 second. Here it is. To extend the range, also we can use our AP. One AP is there who is broadcasting the SSID in this area, and I have one a small area over here, and now we need Wi-Fi network here. So we can use one AP here. We can configure in a different mode so that this AP, newly added AP, will broadcast the same SSID which is running over here, right? So we can use the AP to extend our network coverage as well. Access point can be placed in various locations to extend network coverage, ensuring seamless connectivity. Connecting wireless devices, right, that we already discussed. Allow wireless devices like a smartphone, laptop, tablet to connect to the wire network. And managing network traffic. Access point help in managing and distributing the load of network traffic efficiently, right? Multiple AP can transmit the same SSID and they can distribute the traffic. Let's say I have two AP, AP1, AP2, and guys, 500 clients are there. Each AP has capability to handle 300 clients, right? So automatically these two AP can distribute the traffic, network traffic. Automatically it will balance the user. So these kinds of features are also available on our AP. And how access point works? Access point works by converting a wire Ethernet connection into the wireless signal. They can operate in different mode. First mode is called root mode. Here see the new mode of your AP. The mode of AP, root mode. Root mode act as a main access point in the network, connecting wireless client to the wire network, like this kind of scenario. Similar like your standalone AP, where I have single AP who is connecting multiple client machines. One router, one server is there. That's it. This particular thing is called root mode. The repeater mode, as I told you, you can extend your coverage with the help of AP. In that case, you have to configure your AP in repeater mode. Means that is not the new AP. It will not behave like a new AP. It will behave like a existing AP. It will just extend the area. In repeater mode, the AP extend the range of an existing wireless network by repeating the wireless signals. Just it will, AP2 will repeat the signal. It will receive the signal from AP1 and it will repeat it in different area.
So
Then
what
we
is the benefit of this then?
extending the wireless network,
Okay, load
increasing the
sharing thing you
coverage,
can say. Okay.
increasing coverage. Then we can also configure AP in breeze mode. Like see, if I have guys two building, for an example, I have two building, building 1 and building 2, right? Let's suppose these are two college campus. Here again I have the network. In building, this building also I have the network, but between the building there is a highway. There is a highway, or so many waters are there between the building. So it's somehow, let's suppose mountain is there between the building. So it is not possible to place one cable here between the building. Question: how we can connect these two buildings? Then Praful, we can place one access point over here, one access point here, and these two access point can get connected wirelessly, right? So here you can see these two access points are connecting two wired network together. Am I right?
Yes.
So we can also use our access point in repeat in the bridge mode, which can be used to connect two wire network wirelessly. Here APs are not connecting the clients, here APs are connecting the network. This is all about your access point AP. Now some again the basic fundamental concepts of wireless networking, like SSID. SSID, what is SSID? This is nothing but the name of your wireless network, similar like your VLAN, right? If you need to create two wireless network guys, two WLC, sorry I am saying WLC, WLAN, you need to create two WLAN. So what you can do on your access point, on your AP, you can create two SSID, one with name guest. Getting noise guys, please put yourself on mute. Yes, a student and guest or employee. Three SSID are there, right? It is broadcasting three SSID. It is similar like three VLANs. For the security purpose, we can transmit multiple SSID. So SSID is nothing but the name of your Wi-Fi network. It is what user see when they scan wireless network, right? Like if I am going to scan the wireless network, you can see the name of all available Wi-Fi network here in this area. These are what? SSID. What is BSSID? Basic Service Set Identifier. The MAC address of your access point radio frequency interface. Guys, if access point and the client are going to exchange any traffic, right, definitely there should be an interface from where it will forward the traffic. Interface, right? So the MAC address of AP's interface is called BSSID, right? How you will, both the AP are broadcasting the same SSID guys. Let's say same SSID guest network. How will identify that this guest SSID is coming from AP1 and this guest SSID is coming from AP2? There will be BSSID. When it will broadcast any kind of signal, there will be source MAC address, that will be nothing but the MAC address of their NIC. So SSID is the name of your wireless network, BSSID is the MAC address of your AP's interface. Channel, you already know, a specific frequency that AP used to communicate with clients, and proper channel planning is crucial to avoid the interference. WLAN, wireless LAN, is already clear to you. And now let me tell you about the security. For the security, for encryption, we have these protocols, right? We can configure for QS, we can implement the QS also, we can prioritize the traffic in wireless as well. And security is very, very important in wireless, because your data is going to travel in air. And if data will travel in air, we have to take care about the security. Rogue AP detection.
Sir, is there
Yeah.
Sir, is there any possibility to make a port security same like a wired network?
We cannot configure the port security here. We can bind the user with MAC address, That is going to be similar like port security, but port security is the feature of switch. Okay, now another feature can be rogue AP detection, coverage and capability planning, site survey, RF management, power over Ethernet. Like if there is no arrangement of giving power to the access point, then how your access points will get power from the switches or from any other networking devices. That is power over Ethernet. And the Cisco DNA server, advanced network management platform for automation and analytics. Right? This is all about
सर डीएनए किसी को बोलते हैं क्या?
software defined network. Yes, 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 exactly.
Which manages multiple WLCs.
Exactly.
Okay.
Right. Some other topics like the client roaming. I already told you, client roaming means ensuring seamless connectivity as client move between the APs. Load balancing, distributing clients across multiple APs to avoid the congestion. And these all things is going to be happen automatically. The roaming, load balancing means distributing the traffic, bandwidth management, allocating bandwidth to ensure fair access and performance, guest access, setting up secure isolated access for guest. Here is the basic configuration which we can check over in the packet tracer. Then AP mode, first mode is a standalone mode, and here you can see how a standalone mode will look like. There is no any controllers, no DNAC, no WLC, right? We are going to manage it manually. And the another mode is lightweight mode, which is called controller based mode, where you can see this is the setup. I have one router, switch, WLC. WLC is connected with one management PC and some access points are there. This is your what? WLC. Let me click on my WLC, see how WLC looks like. Right, the console cable and some ports are there, nothing else. Go to configuration and management and let me configure the IP. It's already configured 192.168.1.1. And let me change the submit mask as well. On the management interface, 255.255.255.20, let's say, and then go to your PC and let me show you the main dashboard of your WLC, how it's look like. 192.168.1.10, and let me open the browser, and before browser let me ping 192.168.1.1. Why ping is not working? Okay, ping is working. Let me try to access my WLC. Open the browser and type the IP address 192.168.1.1. You will get access of your WLC. This kind of setup. So here first we'll configure the WLC, guys. On the WLC itself, you can enable the DHCP service, or you can enable the DHCP service on switch, or you can have a separate DHCP server, or you can enable the DHCP service on router for assigning the IP address on these APs. APs will get IP address automatically from your DHCP server. So the first mode is standalone mode, second mode controller based mode or lightweight AP, third mode is breeze mode, but we don't need to learn it. Repeater mode, mesh mode.
Sir, in standalone mode, we don't need WLC then?
No, your AP will not support WLC. Standalone APs are manually managed AP. Manually we have to perform all the configuration there.
Just like we will connect the AP to the switch, and normally it will communicate with the
Yes,
DHCP server.
exactly. Here again you can read about the SSID, about the MAC address. Let me check. So see, I got the access of my WLC here, right? You can create the user. Let me say user is admin, password is admin, that 123. See, I got the access of my WLC. Here is the model Cisco 2500 series wireless LAN controller. Here we can define the system name. Let's say WLC controller, country, date, time zone, NTP server, optional the management IP address 192.168.1.1, the submit mask 255.255.255.0, and the gateway IP address 192.168. Let's say 1.100, and the VLAN is, let's say, VLAN 0. Let me click on next. Here it is asking about the network name. Network name is, let's say, a guest Wi-Fi. Guest Wi-Fi. For the security, here you can see it is asking for the protocol, which protocol you want to use, WPA personal or WPA enterprise. Let me use the personal for now. Here you can configure the password, Cisco 123, confirm password, Cisco 123, VLAN, management VLAN, leave it on default. Let me click on next, and here the virtual IP address, everything is looks fine. Click next and apply. So we are done with the basic configuration. What it's saying, it is saying that your AP will get reboot. Okay, let's click on OK. Now my WLC is rebooting.
WLC will reboot, right?
Yes, now we are done with the basic configuration of WLC. Now we can access it, and we can manage lots of access point from here. We can configure one access point and we can use that for all the APs. Like if I need to create WLAN, wireless LAN, where I will create the WLAN now? I will create the WLAN on my WLC, right? Not on the AP. It will be automatically flooded over all the APs. Saving the configuration. Let me close it and let me try to access the AP again. Sorry, I am saying AP again and again. Extremely sorry, guys. WLC. Let me open the browser and let me type the IP again, 192.168.1.1. I think now it will work with HTTPS. Let me try with S. Yes, you can see this is the main dashboard of your wireless LAN controller. Right here is the login option. You already have the username and password. So now you can log into your WLC. Your controller username was admin and password was admin@123. Let me log in. What happened? Yes, you can see I got the login. Are you able to see my screen, guys? This is the main dashboard of WLC.
WLC.
See here I can create the WLAN. These are the summary information about my WLC. Here I can create the WLAN. Is there any WLAN right now? Here are the ports. You can see there is only one
Sir,
WLAN with
WLAN
name.
means you meant to say APs.
WLAN means wireless local area network. Means one LAN, wireless LAN.
Okay.
WLAN, wireless local area network, means one SSID can be called as one WLAN. So you can see here I have one WLAN with name guest Wi-Fi. Is it visible? Yes. From here I can remove this WLAN as well. From here you can manage the VLANs, WLANs. You can check the AP group. Right now I don't have any AP, I think, but we can add the AP from here. Right here is the controller. Is working slow. Controller information. See, you can enable the advanced security, QS, those all things. Wireless. management, security, right? So this is the dashboard, and you don't need to master the WLC dashboard now. In future, when maybe someone will have interest in wireless, they will become champion in the wireless. At that time, you will learn each and every component in detail. In CCN, CCNP, there is just a theory, right? You should have idea about the WLC, about the DNA center, about the APs, about the wireless fundamentals, about the roaming modes. So from this WLC, I can not only configure, I can monitor our APs as well. I can create multiple WLAN from here. See the ports, summary, access point. Right now I don't have any access point here, you can see. If you want to create the new WLAN, here you can click on create new and then click on go. It will create, it will ask you for the name of your wireless network, and it will create the name WLAN for you, like the profile name, what should be the SSID and what should be the ID. Right? So what is now BSS? Basic service set. The BSS is the basic building block of wireless network, which consists of a single AP and its associated client. If there is a single AP like your home, single AP which is handling their own clients, that type of particular scenario is called BSS, basic service set. If I will draw the diagram, so for an example, one switch is there, one access point is there, AP, and their clients are there. This particular scenario is called BSS. This is one BSS, basic service set. This is BSS is nothing but the domain area, right? In the production network, a BSS represents a single AP and the devices connected to it. And BSA, what is BSA? Basic service area. This is again also area only, but BSA is the physical coverage area of a single BSS, right? The physical, whatever physical area one BSS is going to cover, that will be considered as BSA, basic service area. The physical area and logical area is called BSS. It represents the geographical area within which device can connect to the AP. SSID, BSS, BSS. Each AP and its clients are called what? BSS. I already told you this. Each AP and their BSS is called, their devices is called BSS. Like one access point is there, AP1, and there are some clients. This is called BSS. I have another AP, AP2 at second floor, and they have their own clients. This is called BSS1, this is called BSS2, AP3 and their clients. BSS3 at different floors. See, at first floor we have AP with BSS, this MAC address of AP1. At second floor I have another AP with this MAC address. And this all area is called
BSA.
Yes.
Coverage range of APs, you can say.
Multiple APs.
Yeah, multiple APs.
The BSA is the first floor. First floor AP is the area that cover the first floor. BSA second floor, BSA1, BSA2. Employee can move within the BSA. Like roaming will work within the BSA. Means all floors AP should be in single BSA.
Okay.
Right? Then only roaming will work. Then again the MAC address. about the scanning process, you can see the client device continuously scan for available Wi-Fi network by sending out probe request message and listening for beacon frame from the AP. So what is happening by default? Your client's wireless devices are sending continuously probe signals to scan the AP if somewhere is AP is available. And once your AP will come up, your AP will start transmitting what? Beacon signal. Beacon signal in the air. Right? So how a client machine and AP will get connected with the help of these two signal, probe signal and beacon signal. Each AP broadcasts its SSID and BSSID in the beacon frame. When AP will send the beacon frame, in that beacon frame there will be SSID. Whatever SSID is configured on the WLC, all the SSID will be broadcasted by your AP in the air, and there will be their MAC address as well, so that we can differentiate multiple AP. Like if client is getting the same SSID from two AP, client is going to compare the signal, which signal is better, right? And how both the signals are unique with the help of BSSID only, MAC address only. So you should have the idea of these scanning, connecting devices and client and AP. So see the evaluating signal strength. The client device measure the signal strength, which is your RSSI, received signal strength indicator, right? RSSI only tells my client machine about the signal strength of the beacon frame it received from different APs. So if a client machine, if my laptop is even getting lots of SSID, you can see which one is on top. Which one is on top? This one, right? Where it is getting better signal. Might be possible that multiple APs are broadcasting the same SSID. So here my laptop is going to use received signal strength indicator to identify which signal is better, right? And where this information is available in the beacon frame, in beacon signal you can say, not frame. A stronger signal typically indicate that AP is closer. Yes, that is absolutely true. Then selecting the best AP, client will compare the signal strength of the received beacon frame and it select the AP with a strongest signal, which is likely the nearest or least obstructed AP. Because see now, if multiple APs are broadcasting as same SSID, let's say guest, and you are now closer to AP number 1, so you are going to connect with this AP, it will ask you for password. You have given the password is correct, successfully you have connected. Now when you will move towards AP number 2, it will not ask you for the password again, because you are already in the WLAN. You are already the part of my wireless network. And this AP is also broadcasting the same SSID, means both the AP are in same WLAN. So your device will be keep checking the signal strength. Once it will get better strength from AP number 2, it will disconnect from AP 1 and will connect with AP number 2.
And this happens in roaming case.
Automatically, yes, in roaming case. Right? So this is how your client machine is going to select the AP. Then connecting to AP, how client machine is going to now connect with AP. Let's say device client machine has selected that, okay, I am near to this BSSID, means AP1. Now how it will connect? So to connect, client will send one association request message to the AP. Which message? Association request message, which will also carry the BSS ID of your AP, because again my client machine is sending the message in air. AP1 and AP2 both are there. How AP1 or AP2 will get to know that this association message is for me or for another AP? With the help of BSS ID. right? How client machine is detecting, guys, which AP is transmitting the better signal with the help of BSS ID, the MAC address of your AP's interface, right? And how client machine is sending association message to a correct AP with the help of, again, BSS ID, MAC address.
Means a client will send PSS ID
Yes,
in response to the association message.
correct. And after that, AP will send association response message to complete the process, and then your client machine will get connected with AP, right? Here are the detailed explanation about the AP selection, connection process, scanning process, and continuous connection. There are examples, some real-time example, right? I will share this PDF, you can go through it. Again, SSID, multiple time SSID is there. Don't know who have created this. Text is my, but the designing is of graphic designer. Yeah, right? Okay. Now if you want to see the antenna, so see the antenna as well. Types of antenna: omnidirectional. Omnidirectional means radiate signal in all the direction, 365-degree horizontally. Directional signal antenna can be used to direct the signal in a specific direction or in a specific area. This is used for long distance, like as I told you, to connect two wire network, I can use my AP in repeater mode, sorry, breeze mode. Then sector antenna is also there, cover a specific sector, a specific team, some other key characters are there, and you can ignore it. Theory wise we are done. Let's do one lab for the wireless here. Let me show you how you can manage the APs with wireless controller. Let me take you to wireless devices here. Let me take few APs. Let me take the WLC first. Let's say this is my WLC, and some access point. Lightweight AP, I need lightweight AP. Here it is, lightweight AP, you can see. Let me say 1, 2, 3, let's say 3 APs or 4 APs, and I am going to use one switch to connect these all APs together. Let me connect it. First of all, we need to change the display name. You can click on the AP, or from here also you can change the display name. If I am going to click on AP, here you can see how my AP, this Cisco AP looks like. This is the Cisco AP. Go to the configuration. What it's saying, device must be power on. Device is not power on now. You can see even there is no power cable, but here is the wireless power cable. Let me connect it. So we are connected, and now we are on the WLC configuration tab. Here I can configure the display name. Let me say access point 1 or AP1. AP1, you can see automatically name is changed. Here I am going to on this AP as well, AP2. Let me add this power cable and config 2 and config T. Let me say AP2 access point 2. Let me say access point 3 here. AP3, and let me turn on this AP as well. AP4. So how many APs are there? I have 4 number of AP. And how many WLC are there? 1 WLC. We can change the display name of WLC as well. I can say WLC controller. Now my name is changed here as well. You can see this is my WLC, or let me say WLC only. Okay. my WLC, AP1, AP2, AP3 and AP4. These all APs are on. Now we need to add these APs on my WLC. Let me access my WLC once again, and you can also access your WLC through a PC with the help of management interface. Here in the configuration tab, you can see the management configuration. Here we need to define the IP address of WLC. Let's suppose IP address of WLC is 10.1.1.5. The default gateway IP address is, let's say, 10.1.1.100, and submit mask is 255.255.255.0, and DNS server IP address is also required. You can even ignore it, but let me configure it 1.1. Let's say 6 is the IP address of DNS, right? So I need to configure this WLC. Here I can set IP 10.1.1.5, submit mask 255.255.255.0, default gateway 192, sorry, 10.1.1.100, and the DNS server IP address is 10.1.1. let's say 6. The management interface configuration is done. Now here we need to add the API, and we need to enable the DHCP service as well, so that my APs can get IP address. Before that, we can do one more thing here. See, AP group, and I don't have any AP now. WLAN is also there, but we don't have WLAN. We can create the WLAN here. We can define the SSID. For an example, PM underscore Wi-Fi is my Wi-Fi network, wireless network. Here I can select the security protocol, let's say WPA, and password is, I'm saying 123456789, and then we can save it. Click on new. Then what happened? PM underscore Wi-Fi, name of your wireless network, Wi-Fi VLAN 0 123456789. WPA key must be 10 character. Okay, 10 and let's say 0. Okay, done. You can see we have created one WLAN, right? We need to add now access point here. We need to add APs here. Access point, you can see access point, but there is no any access point, and here is one option to add new access point. Let me add the access point. Let me click on new, and this is, I think, different. AP, go to wireless LAN. Click on new here. Name, let's say AP1. AP1. SSID same. 1 2 3 4 5 6 7 8 9 0 and save.
सर ये तो SSID अपनी ऐड होगी बेसिकली।
एक मिनट, इसका थोड़ा सा सिस्टम APs are not online here. Let me configure the DHCP service first. On the service, pool name is, let's say, PMNet. And default gateway was 192.168. Dot. What was the default gateway IP?
10.100 था।
Sorry, 10.1.1.100.
1.100।
The DNS 10.1.1.5. The starting IP address is, let's say,
DNS was
10.
6.
DNS
5
is
was
6.
management IP.
10.1.1. Let's say I'm saying start IP address from dot 200, submit mask 255, 255, 255 dot 0 and TFTP. These all are not required. Let me click on add. Maximum number of user, where it is here, maximum, let's say 50, and click on add it. Go to the AP ones, and here let me try to select the DHCP. Now you can see this AP got the IP address, right? The DNS server gateway IP address access point 2 should also get the IP. Let me change. Yes. 3 4. And now let me take you to the WLC and go to AP group, and now you can see your AP1 and AP2 are online. Status, see the status over here. AP1 and 2 are online. Rest APs will also come online. Yes, see, all the APs are now online, and we have some wireless network as well. Now if I am going to drag and draw some wireless client devices, let's say this PC or the smartphone, then a smartphone, click on a smartphone and go to their wireless adapter. Here it is, wireless adapter, and define the SSID. What was the SSID? PM underscore Wi-Fi. Let me put that SSID here, PM underscore Wi-Fi, and for the password I had used WPE protocol, and password was 1 2 3 4 5 6 7 8 9 0. And let me check this machine, this smartphone is able to connect. Yes, you can see it is get connected with AP number 4. And let me check the IP address of this smartphone. IP config. The client machine don't have IP address. Let me try to assign IP address from the DHCP server. Yes, 10.1.1.205 is the IP address of this client machine. IP config. Here it's showing the IP address, right? Similarly, here I have a PC. Let me add a wireless adapter here on this PC. Turn off your device, remove this, and add wireless management port here. Wireless management port, and then go to wireless section and define your SSID, PM underscore Wi-Fi, and the name was what? Sorry, password was WP, and password was 1 2 3 4 5 6 7 8 9 0. And now I am expecting this PC should also get connectivity with AP. It's connected. Why it is connecting with AP4 only? Okay, it will take some time. These are the issues of packet tracer, right? It will automatically distribute the user here. And similarly, I can have some more devices like laptop, and on the laptop also we can turn off the device, we can remove this adapter, and we can add wireless management port here. Then we can turn it on. I can configure the wireless SSID, PM underscore Wi-Fi, and the password is 1 2 3 4 5 6 7 8 9 0. Okay, now see the IP address on the laptop. IP config. It is taking time. Yes, IP address is 10.1.1.209, and IP address on the smartphone is what? 25205. And if I am going to ping, guys, if I am going to ping, will ping work?
It has to be.
Definitely ping will work. See, I am going to ping from here to 205. Ping 192, sorry, 10.1.1.205. See, ping is working, right? Means the laptop
Mhm.
and a smartphone are able to communicate. Now, how they will communicate? The packet flow. So guys, what I told you, between all the APs and WLC, there is a tunnel. Which tunnel?
Cap web.
CAPAP tunnel, right? Here also we have CAPAP tunnel. Here also we have CAPAP tunnel. and here also we have cap up tunnel. So what will happen, this PC, this smartphone is using IP 10.1.1.205 and this one is using 10.1.1.2010, let's say 210, 210. What will happen if I will ping this IP address from the laptop? It will generate ICMP packet, ICMP request message, and in the ICMP request message here there will be source IP, destination IP, source MAC, destination MAC, right? Destination MAC will be what? The MAC address of gateway, and the laptop will forward it to AP2. AP2 is going to forward this frame to WLC, but not directly. First this AP will perform encapsulation of cap app. It will add some extra information here and then it will forward to WLC. What WLC will do? WLC is first going to perform decapsulation, right? Then it will compare some information like the MAC address with their table, and then it will again perform encapsulation, and then it will forward from this tunnel, and then like this traffic will go. It is similar like the GRE, right? R1 connected to internet and R2, and here we have, let's say, GRE, right? Here we have subnet 10.1.1.0, here we have subnet 20.1.1.0, right? So if 10.1 want to communicate with 20.1, user will forward traffic to router 1. On router will find exit interface is a tunnel interface. Router will perform what? Encapsulation. Am I right? It will add one extra IP header. Source IP, destination IP will be public. The tunnel source, tunnel destination. Similarly, it will perform encapsulation. Both the access point will perform encapsulation, decapsulation whenever wireless clients will communicate with each other. 1 minute, guys, please. So this is going to be your packet flow. Now you can ask Praful, if here is one another user, if these two users are going to communicate with each other, still traffic will go via cap app tunnel. So you tell me this, if these two users are going to communicate with each other, traffic will go directly or traffic will go via WLC?
So via AP only, I think.
It's depend. If both the clients are in same VLAN, means are using the same SSID, then they will communicate directly. But if this client is, let's say, the guest user has joined the different SSID and this client has joined the different SSID, let's say PM_Wi-Fi. In this case, traffic will go via your WLC. Right? So what you can do, you can also design a wireless network in the packet tracer for practice. You can create a network of a building. Let's say 3 floors are there. At each floor we have 2 APs. Right? And we have one WLC. And see, I have not configured these AP, guys. These APs automatically sense your WLC, and on the WLC only I have enabled the DSCP service. And they all APs got the IP address from the WLC. They have discovered the AP. They have established the cap app tunnel, and now users are able to communicate with each other. And trust me, this is more than sufficient for CCNA and CCNP wireless. If you are looking for the certificate paper, exam paper, this is the more than content.
So, sir, tap-up tunnel, as you said, means any mechanism goes like a whitelisting or certification based or something like that. Fine.
Certification.
Means certificates they exchange, similar kind of TLS tunnels, or it is not like that.
Yeah, it is similar like the control connection. Yes. See,
Okay.
actually, your access points and WLC are going to create two CAPAP tunnel. Will create two CAPAP tunnel. Why two CAPAP tunnel, guys? One for control plane traffic and one for data plane traffic. Right? So at the initial time, when your APs are going to establish the control connection with your WLC, right? That is called control connection. Similar like the control connection, DTLS control connection, TLS control connection. It is also similar like that. And this CAPAP kernel tunnel is used for data, user data, user data, and this is for control plane traffic, like to flood the SSID, WLC, any policies, right? So let's say you need to configure some policies that the particular department or guest user should have the limited access of internet, should only be allowed to access YouTube and Google. That's it. So this is your policy where you will apply the policy on WLC, and how WLC will push it to access points through control tunnel, right? If I'm going to create any more SSID, it will flood to APs through the control connection. If I'm going to configure any policies, any security, any QS, everything will be pushes to my APs through control connection. And how AP and WLC are going to establish the CAPAP tunnel? Definitely they will exchange some messages like CAPAP request message, CAPAP response message. Access point will send the request message, CAPAP request, and your controller will send CAPAP response message. Hope it is clear.
Sir, how can we suppose if we want our smartphone should connect only via guest only, guest SSID, not the main user SSID, like PM SSID.
So here you will define that na SSID. Here when you will client will scan, they will get all the SSID,
Correct.
right? But I can only connect with that whose password is known for me, right? If I know the password
Okay,
for this
matching
one, then
matching
only.
password only.
Yes.
Yeah. Okay. Okay.
So guest user will only have the password for guest Wi-Fi, and my company
Lab-
employee will have the password of my company Wi-Fi.
Got it. Got it.
So we have seen the dashboard of WLC. We have seen the basic lab, basic fundamentals of wireless networking and wireless components. Hope it is clear. Can I close this lab, guys?
So it's a wireless controller